Okay, we're going to look at the second question here. This question was, what's the point? So in the earlier example, we were looking at all of Alameda and Santa Clara County. We had a very large sample size. Now we're going to limit ourselves to just the people who live in Fremont, which, if I'm right, it's 1009. So it's 1009. So now our sample only has 2,226 rows. So the sample size dramatically decreased. And now we're going to ask the question of what percent of the people are older than 65. I don't think I have that bin properly. What we can do is we can just go to 65 and older. This is a simple way to do it, not the way I would probably do it if I was going to show you really in a class, but this is the fast way to do it. We want to know, what percent of people are over 65. So actually we want to go over 65, so we need to go one up. We got to go to 66. So we actually see that it's 347 out of 2261. So that's my starting point. So this is called the point estimate. The point estimate is what comes from the data. So I should show this differently, I think. I'm a little afraid that if I don't show this the right way, you're going to have a little bit of confusion. So let me go to bin. Let me go to age. I want to show you a table. So what I want to do is I'm just going to make a really quick table here. I'm going to make a really quick variable. This is over 65, and this is 65 and under. So this is just a quick age binary variable, age of 65 or more. So I'm going to, again, I'm going to grab just the people from Fremont, create my table, and then I'm going to create a table. I'm just going to make a frequency table with relative frequency of the new variable, age 65. And I see that for Fremont, it's actually 15.3. It's 347 out of 2261. So that becomes my point estimate, 347 out of 2261. 61, which is equal to 15.3%. So in the old days, this would be all we would do. We would just have a table. This would be our result. But now what we're going to do is we're going to add into this the confidence interval. So we're going to go to our bootstrap. We're going to enter in the data. So again, the data was 347 out of 2261. 347 out of 2261. We type that in. I get the 15.3%. And then again, we generate a bunch of samples. So you can see we generate a bunch of samples. I just go right to the 1,000. I was just kind of showing it, going a little slow there. So I generate a bunch of my samples. I ask for the computer to find me the two-tailed, which is two-tailed just basically gives me the lower bound and the upper bound. So in my earlier example, I had 15% for all of Alameda and Santa Clara County. I had a very large sample size, and I was very confident in my result. I knew that my result, even though the point estimate was only 15%, I knew I wasn't off by a lot. We actually calculated the margin of error to be 0.35%, so that's less than 0.5% off that we could be. Could be as high as 15.4, it could be as low as 14.7. Now in this situation, because sample size is much smaller, it's only at 2,200 people, 2,000 people, even though I have a 15.3 as an estimate, it could be as low as 13.9 or it could be as high as 16.8. So this is it's a wider spread. I mean, it's still, we're in the ballpark. We have a pretty good idea of where it is. It's definitely, it's less than 20%. It's less than 18%. It's somewhere like, it looks like less than 17, and it could be as low as like maybe 14%. But it's a pretty wide range here. So we would write that answer in. We're going to go, it's going to be from 13.9% to, what was it? 16.8. So this would be what I would call my confidence interval. I'm 95% confident that the true value of the proportion of residents in Fremont over 65 is somewhere in this range. I don't know where it is. It could be 14, it could be 14.5, it could be 16.8, it could be 16, it could be 15. We don't know. I mean, it's the fact, this could be right. It could be exactly 15.3. But knowing about variability, we really only can really say it's somewhere in this range. We'll never know because we can't go out and sample everybody in Fremont. So that's this question. Next question is probably a margin of error. Oh, how does Fremont's range? So hopefully you notice that Fremont's range is quite a bit wider. If we wanted to think about the width of this, so the width of Fremont's range, confidence intervals range is, so what's the numbers? 16.8 minus 13.9. 16.8 minus 13.9 in percentages. What does that look like? It's a little under 3%. I think it's 2.9%. My math right? I think so. 2.9. When you had all of Alameda and Santa Clara County, this is not Alabama and South Carolina, but if you had all of Alameda and Santa Clara County, the interval was only 0.7%. So you would say that the Fremont's width is a lot bigger. Fremont's width is much bigger. It looks like, if you think about it, 0.7 goes into 2.8 about 4 times. So we would actually say it's about 4 times. 4 times wider. Last question, I think. Oh, so I should have asked what the margin of error was here. So let's do the margin of error calculation. The margin of error calculation, if we want to calculate margin of error, it's going to be the width of the confidence interval divided by 2. So if we do this math here, we get 2.9% divided by 2. That would give us 1.45%. And we should sort of see that if we added 1.45, so say we add 1.5, that would get us to 6.8. If we subtracted 1.5, we'd get to 1.38. So we're pretty much in the right ballpark there. It's going to always be just a touch off if your percentage is not exactly 50%. Only 50% percentages will be exactly uniform left-right. Last question, what can we conclude about Fremont's true population of those over 65 is different than the overall average for Santa Clara and Alameda County? Maybe we stay away from this question. If we want to know the basic story here, if we looked at this, we have confidence intervals here, so you could kind of compare the confidence interval. Confidence interval for Santa Clara is 14.7 to 15.4. This is Alameda and Santa Clara County. The confidence interval for Fremont is between 14 and 17. So they could be, Fremont's could be different, or it could be the same. It's inconclusive, right? Because Fremont's could be exactly in this range, or it could be much higher, or it could be a little bit lower. So we actually don't know the answer to this question. Can we conclude is different? We don't know. It's could be different, might not be different. I want you to think about, though, why did I get to that answer? All right.